Ever wondered how you find hidden groups or, secret structures inside really complex networks? Well, today we're diving right into that puzzle with a kind of data detective story, a tale of two very different algorithms.
So take a look at this. What you're seeing is a map of social connections in a classroom. Every red dot is a person, and every gray line is a connection between them. And yeah, at first glance, it just looks like a total tangled mess, right? A chaotic jumble of dots and lines.
But here's the thing. Think about any social group you've ever been in, a classroom, your office, a neighborhood. There are always smaller groups, right? Cliques, close friends. They're hidden inside that larger structure. So the big question is, how on earth could we find them just by looking at this map?
Well, it turns out there's a whole field of science dedicated to solving this exact problem. It's called community detection. And it's all about creating these clever methods to automatically find those hidden, really tightly knit groups inside a much bigger network.
To do this, data scientists have basically developed these special tools, or algorithms. And for today, I want you to think of them as two expert detectives. They each have a very different strategy for uncovering the truth. So let's see what happens when they both investigate the very same case. Okay, our first detective is the Girvan-Newman method, and I like to call this one the bridge remover, because its entire strategy is about finding what holds the network together and then, well, taking it apart. Here's how it works. First, it scans the whole network and it finds all the bridges. Those are the connections that are most important for linking different parts of the network. Then it strategically removes the most critical bridge, and it just keeps doing that over and over, cutting away the connections between groups until the network just naturally falls apart into its separate communities. It's what we call a top-down approach. And boom, here is the result. Remember that chaotic math of red dots from before? This is that exact same network, but after the Girvan-Newman method has worked its magic. All of a sudden, we can see these clear, color-coded groups. The chaos, now it has structure. So what did our bridge remover detective actually find? Well, its analysis uncovered 26 distinct communities within this one classroom network. Now, to grade how well these groups are defined, scientists use something called a modularity score. Just think of it like a grade for how good the groups are. The higher the score, the stronger the connections are inside the groups compared to outside. Girvan-Newman's map scores a 0.7012. All right, keep that number in mind. Okay, time to meet our second detective, the Louvain method. Now, if Girvan-Newman is the bridge remover, then Louvain is the group builder. It takes the complete opposite approach. You see, the Louvain method starts from the bottom up. It begins by treating every single person as their own tiny little community of one. Then it goes person by person and asks, hey, if I move you into your neighbor's group, does that make the overall structure stronger? It just keeps merging people and small groups together, always trying to get that modularity score as high as possible until it literally can't make any more improvements. And here is its result. This is the exact same network, but now we're seeing it through the eyes of our group builder. Notice anything different? The colors are shifted around, and some of the groups definitely look a little different in their size and shape compared to that first map. The numbers also tell a different story. The Louvain method, it found 24 communities. That's 2 fewer than Girvan-Newman found. And what about its modularity score? Louvain gets a 0.7080, so that's actually a little bit higher than Girvan-Newman's score. It suggests that, at least by this one metric, the groups it found are just a tiny bit more tightly knit. So this is really the heart of our story. We've got 2 expert methods, and they've given us 2 different maps of the exact same social reality. And this is where things get really, really interesting. Seeing them side by side like this makes the differences so obvious. On the left, you've got Girvan-Newman, and on the right, you've got Louvain. Just look at those central clusters. Girvan-Newman splits them into separate green and blue groups, but Louvain sees one single large blue community. They're telling 2 completely different stories about the same network. So let's look at the final tally. Girvan-Newman found 26 communities with a score of 0.7012. Louvain found 24 communities with a slightly better score of 0.7080, but the crucial point here is that they disagree, and not just on the number of groups, but on who actually belongs in them. So who do we believe? Which detective is right? Well, this leads us to probably the most important insight of this whole thing. Maybe there isn't one single correct map. See, it all comes back to their different philosophies. Girvan-Newman's top-down approach is designed to find the major fault lines, the big divides in a large population. Louvain's bottom-up approach is built to find the most tight-knit, cohesive little local groups. They're asking fundamentally different questions. And because of that, each algorithm reveals a different but equally valid truth about the network. It's not that one is wrong and the other is right. They're simply giving us different perspectives on the same complex reality. This quote really just sums it all up perfectly. Choosing the best method isn't about finding some ultimate truth. It's about deciding which map is the most useful. For a teacher looking at this classroom, one map might reveal the best project teams, the really tight collaborators. The other map might highlight the major social divides, the potential cliques or factions. Which leaves us with a final thought. When we use data and algorithms to make sense of our world, the tools we choose literally shape the answers we get. So which map of the social world is the right one? Well, the answer might just be, it depends entirely on what you're looking for.